going to talk a little bit more about this concept of mean. I want to bring up a couple points of focus here. So number one is we want to be a little careful about what types of variables we actually take the mean of. And the reason for that is that the mean can be extremely informative about the variable, but only to the level at which the numbers within that variable make sense in relation to one another. So let me be less cryptic and say the mean makes more sense when we talk about an interval or a ratio level variable. So if you recall back to chapter 1, we talked about the levels of measurement, and so what I'm really highlighting is we want to be careful when we have ordinal data. Okay, so think about first, second, third, fourth in a competition. If we want to think about taking the mean of those places, it may not be giving the information that we think it is. And let me be a little more specific. So if I've placed first compared to second, and then later I placed fourth, taking the mean of all of the, if I placed first, then second, then fourth, taking the mean of those gives those values don't necessarily equate to 1, 2, and 4. And what I mean by that is that we want to make sure that we're not attributing the same difference between first and second as we necessarily are between second and third. So, for instance, somebody that places first, second, and fourth, if we were to take the mean of that, I should have made it easier on myself, but what is that? That's 7 divided by 3, which is 2.33. Okay. Now, if let's compare that to somebody that gets second, second, and second. That obviously is going to be a mean of 2. Okay, and now mu is equal to 2, and the mu is equal to 2. Now, looking at it just from a mean finish, we may say that let's just say player B and player A. That's kind of off the screen, but A and B. We may say, oh, B has a better average or better mean finish. But this is requiring us to assume that the distances between the different places are equal. And in reality, we may favor, and maybe we could have a discussion about which one should be best, but there's no definitive reason that you would want to finish second 3 times in a row rather than have a win, a second, and a fourth. Okay, and so using the mean to calculate ordinal data doesn't elicit the same type of valuation that it does for interval or ratio data. And so just something to keep in mind. You will see quite often people use this, especially in sporting. The Colts have averaged a second place finish over the last 5 years. So you will hear this quite often, but just a word of caution when we think about actual statistical measures. There's other aspects to be factored in, especially with ordinal data. The other thing I wanted to highlight is that when we think about the mean, an important concept is that the deviations from the mean. So let's go back. When we first talked about mean, we had let's see, I think we had you, your sister, your brother, your grandma, and it was something like 7. 6, 3, 4. Those were not the numbers. Those were the numbers, just maybe not in the same order. Anyway, the deviations from the mean are going to sum out to 0. What are deviations from the mean? So we already calculated this, but the mean is, remember, it's sum of x over n. So it's 7 plus 6 plus 3 plus 4 divided by 4 is 5. Okay, so the mean is 5. A deviation from the mean is simply, so if this is the Cobb's, I think there's 2 B's in Cobb's, then the deviation from the mean is 7 minus 5 equal to 2. Okay, so how far away is this specific value from the mean? So this is going to be 1, this is going to be -2, and this is going to be -1. Okay, and you can think about it either direction. I guess here I've put the value minus the mean. It doesn't matter if you put mean minus the value. It's all going to work out the same. What I want to drive home is that, so first, these are what we refer to as deviations. And secondly, if we sum these up, they're always going to be equal to 0. Right? 2, 3, minus 2, minus 1. It's always going to be equal to 0. That sum of the deviations.